Okay, so today I am doing a binary search. It's not new, it's not rocket science, but why am I doing a binary search demonstration? It's because why do I do any of this stuff? Every time I do this, I know it helps me learn a bit more, and I think about it in a different way. I think about other code that I've written since then, and hopefully I'm helping somebody else out there, at least a few people. Anyway, so here we go. I'm going to walk through a binary search, kind of what it does, how it works, all that cool stuff. When I was making my tea today, I picked my Providence St. Joseph Health Digital Innovation Group mug because I did contract there for a little while. And I just hit my tooth. I have fond memories of being there. It was a cool place. If you're watching Providence St. Joseph Digital Innovation Group, I will gladly come back. Okay, binary search. What do? We have an ordered list like this one. I made it very simple. I made it very small for video purposes. When you're working through your own algorithms, you might want to a little bit longer of a range and with some more variety in your data. Okay, so the way this works is you pick a value, pick a target. Let's say my target is 2. Target is 2. Target. And I don't know, you don't know the letters or anything in here. So the first place you go with binary search is in the middle. You go to 3. Like 3 is your starting value. 3 is greater than it. Now, I don't search the whole thing again. I'm only going to search where I know it's possible to be it. So where is something less than 3 going to be? It's going to be to the left because it's going to be a sorted list here if you're using a binary search. So I'm going to search this half here to my left. If it was greater, if I got 3 back and it was greater, I would only search this part. Okay, cool. So that's what I love about binary search. And what are some cases? So fast fails, fast returns. There's more cases you could do here, but I just laid some stuff out here. After thinking this through, I started thinking about my fast fails. If it was 0, I return false. There's nothing there. If it's 1 and the one element that's in the array there is equal to the target, return true. All right. Now, I know that I need to. Binary search tells you need to always be shifting where you're looking in the array, right? Shift where you're looking in the array, so you either you're in the right range, but it's not there, or you hit the right range, the right element, and it is there. Excuse me. So how do we divide it down to what we need? We know what direction to move in. We know where we started. So if my start was the middle of the entire thing, well, if I now have what binary search teaches you is you have a minimum and a maximum. So you start out, minimum is here, and your maximum is here. Well, what I think about the maximum is it's the length minus 1, that way it's always a real value. So length minus 1 on this side, and this side being 0. All right. So instead of saying length divided by 2 or math floor, because we round down length divided by 2, you would do min and max. Min plus max, divide that by 2, and that means you could then bump up your minimum, divide by 2, or bump down your maximum, bump up your minimum, add to the maximum, divide that by 2, or bump down your maximum, come down this way, bump down your maximum, add to the minimum, divide that by 2. You always get your new middle. Okay, now what if this was an even number of elements? If it's an even number of elements, we're going to get into that, but as long as we're always rounding down, I find it's safe to round down, then it's okay. Because let's say it's 4 divided by 2 would be 2, 5 divided by 2 would be what? 2 remainder of 1, and rounds down to 2, or 2.5 round down to 2. So we're always, that keeps it safe for us with the varying lengths of the list. All right, so we're going to have the fast fails here, and the fast success or a fast return, I set my minimum to 0, just kind of like I said. A minimum index to 0 and a maximum index of array.length minus 1. All right, great. And here's what I was just talking about, the middle index, mid-I. I'm going to floor, math.floor, minimum plus the max, minimum index, maximum index, divided by 2. All right, so I've left this part out on purpose because I think that's kind of an interesting little topic to talk about. I'm going to save that for last. All right, how do we start doing this? We need to look at the value of mid-I. Okay, array sub mid-I. What about mid-I? Well, if that's equal to my target, I'm going to return true. Now what I need to add is my proper syntax. If we got that, return true. Okay, so we didn't get that. What if what we've hit again? What if what we've hit where the middle index is right now, the value of the middle index? What if that's greater than the target? So that would mean that what we've hit is somewhere out here. We're greater than the target, right? Greater than the target out here. So we want our maximum to move down. Let's move down the maximum. So, the maximum index, so move the maximum index down. Max index, and how do we move it down? We want to move it down by the where the middle index was, and we're going to subtract 1, so we're going to look at that to the left, less than where we are now. That makes sense. Equals middle index minus 1. Good. Okay. And then else, the opposite of this case, we know it would have to be, now we're less than it, we're less than our target. Now I want to move up this way, so move up the minimum. So minimum index equals middle index plus 1. Now we're moving that way. Okay, so let's see what we got here now. These things are defined. I've left that blank. I have I'm getting my value, my index of my value. My timer's going to go off here, so just hold on 1 second. I'm going to pause that. Now I know we're getting a little long. All right, so I have all my conditions set up. If I'm equal, if I'm greater than, and then if I'm less than. How do I know if I need to keep going or not? I could say the minimum is greater than or equal to 0, and that the maximum is less than or equal to the length, right? The length. But that would mean that my minimum could keep growing and growing and growing and never stop. It also means that my max could keep getting less and less and less. What does that mean? My minimum is going like this. It's going up here. And then my maximum is going down here. So basically, by observation, I would say I don't want these to cross. So they're not going to cross. How do I put that into code? My minimum is always less than or equal to my maximum. Less than or equal to my maximum. And that would be it. Yeah. So I'm going to trace through this real quick. I'm going to put you guys on pause for a moment. And I'll be right back. If I can find the darn pause button. Pause. Okay, I'm back. This video is getting long, so I have 30 more seconds to do a run through with you. So let's make it something fairly quick, like what I did before. So my target is 2. Is 2 in this list? Let's find out. So the target is, let's erase this, erase that, erase that. Target is 2. Minimum 0, maximum is out over here. Array.length minus 1. So 1, 2, 3, 4, 5. This is 4. Excuse me for a second. Okay, continuing on. Min index is 0, max index is 4. Is 0 less index? Is the min index less than the max index or equal to it? Yes. Min index is equals to min plus max divided by 2. 4 divided by 2 is 2. So we're at 0, 1, 2. So right now I'm at 3. 3 is greater than 3 is greater than target. So max I right here, we're greater than it, equals middle index 2 minus 1. So 2 minus 1 is 1. So this becomes 1. 0 plus 1 is 1. 1 divided by 2 is a half. We floor that, we get 0. Okay. So this one is now 0. Is 0 equal to the target? 1? No, it's not. It is less than it, so we jump down here. So now minimum index is equal to middle index plus 1. So that would be 1. 1 plus 1 is 2. 2 divided by 2 is 1. We've hit our target. We got it here. Boom. We are done. Return true. Sorry that was a little lengthy, but that was a lot of fun. Hope you guys had fun with it too. See you next time.